Okay, so in this video, we're talking about the graphing characteristics, namely the maximum minimums, and whether or not if a function is increasing, decreasing, or what it would look like if it were constant. All right, so this is something that I expect to be review. There is the formal definitions up here. I'm just going to go over them just very briefly, and then we're going to get into the example. This is a very intuitive notion that if a function is increasing, you are rising to the right. Remember when we read a graph, we read it from left to right. So if you are rising to the right, you are increasing. And again, if you are falling to the right, well, then you're decreasing. And when you have some turning points in a graph, things are created called maximums and minimums. And then you have a maximum point, which would be like the highest, the maximum y value, the highest y value of the graph. Now, sometimes that can be a maximum. I'm sorry, that could be a local, also known as relative, or it can be absolute. And so it's very intuitive also. When we say an absolute maximum, that would indicate the absolute highest y value on a graph. Likewise, if I said minimum, it's going to be the absolute smallest y value of a graph. So let's just take a look at these so we can get into the practicing and looking at how to interpret graphs. So it says find the intervals. So I want you to give me the interval notation of the following. So when we're talking about intervals, we're talking about the x-axis, that independent x-axis here, which in this case is t. So we're looking for increase. So if I look at the graph and I'm trying to find where the graph is rising to the right. So I can see that the graph is rising to the right from here, 1, when x is 1, and from when x is 3, and then also from 4, and then on. So the increase is going to be, now this is going to be very important. These are never, never, never going to be brackets. We are always going to be utilizing parentheses because at the exact moment at 1, it is neither increasing or decreasing. It changes from, there's a turning point. We'll get into that later. Just for at least right now, we're talking about the interval of increase is going to be 1 to 3. Right? Not including 1 or 3. Remember, we're always going to use parentheses. Union, and we pick back up at 4, and we go to infinity. Right? So make a little self to your note that you will always, when you're describing, you'll always use parentheses. So now let's do another color and talk about decrease. So again, I'm reading the graph from left to right. I am decreasing from negative infinity all the way to 1. And then I'm also decreasing from 3 to 4. And notice that when we read our increase and decrease, if we were to look at going from least to greatest, it would cover the entire domain of this function. All right, we have -1, or negative infinity to 1, that you're decreasing, and then from 1 to 3, you're increasing. And from 3 to 4, you're decreasing, and then from 4 to infinity, you're increasing. So is there a constant? And a constant in this case is going to be none. And what that would look like is a horizontal line. All right. All right, so we don't have any particular horizontal lines in this particular example. So now when I say find the locations, I want you to give me as an ordered pair. So let's take a look at what those are. So relative or local means that any particular maximum point on the graph. So let's take a look and see if we can find a maximum point on the graph. So a maximum, again, is the highest y value in a region, right? You're going to go from increasing to decreasing, and that's going to create a maximum point. So according to this graph, this is the only one that I see that would be a maximum. So the location of that is going to be 3, 1. So I want the ordered pair of that. Now let's take a look at the minimum. And a minimum, again, is when a minimum is going to look like this. So it's when you're going from decreasing to going to increasing. okay? Remember, a maximum is going to be the opposite, right? We're going from increasing to decreasing. So here I can notice that I have a minimum here, and I also have another minimum here. So there are two minimums. So I've got a minimum at 1, -1, and let's call that 4 and I don't know, 3/4, 3/4, 0.75. All right, because we're looking at that y value right there. All right, so now we're going to talk about absolute maximum. So an absolute is absolutely the highest y value on the graph. And because there are arrow tips indicating that the y values continue to go on to infinity, there is there's none absolute maximum. But however, let's take a look at our minimums. So we have a local minimum, right? We've got two local minimums. Which one of those is the absolutely lowest of the low, which is the smallest of the small? And so the absolute minimum is going to be at 1, -1. Now remember that that keyword was location. So with locations, you give us ordered pair, and that's going to contrast to this next part, which says find the value. And so if it's the value that you're asked for, it's only the y. It's only the y value that you give me. So since we've kind of already found the relative or local maximum, the relative and local maximum was at 3, 1, right? So at 3, 1, I only want the y value, so that's just going to be a 1. And we have a relative local minimums. Our local minimums, we've got our y value at -1, and we also have a y value at 0.75. So you're just really just identifying the y values from those locations. And an absolute maximum, remember, there was none. And the absolute minimum. So on this absolute minimum, the y value is -1.